We get a lot of questions about Theriome's testing platform and how it might differ from Genova Diagnostics metabolome test or Great Plains metabolomic test. So we just want to get into a little bit how this test actually differs from other metabolomic or metabolic tests that currently exist on the market.
Great question, Micah. Simply put, Theriome differs in the breadth of data that we collect, as well as the depth of analyses that we perform. When you look at other metabolomics assays on the market, particularly the ones you mentioned, the metabolomics from Genova, they are measuring roughly 40 metabolites, and they are analyzing them in what's known as a univariate fashion. So they're looking at known levels or prescribed levels, if applicable, and they're saying you have low or high glutathione. So maybe you should take some glutathione. What we do is analyze more data. We are analyzing 126 metabolites to their 40. And these metabolites are not just endogenous, nor are they just indicative of nutritional status. Many of our metabolites have to do with lifestyle factors. For instance, they are indicative of environmental toxicity. They're exogenous metabolites. They are non-organic metabolites in the body. There are metabolites that are indicative of lifestyle that are included in our panel, such as ibuprofen or caffeine, that are noticeably absent from other panels. And that allows us to, for instance, in the case of glutathione, take a bird's eye view of the biochemical circuitry of an individual and assess why glutathione levels are low. Because we are able to monitor other metabolites in the known pathways of glutathione, we can come to a more ontological answer as to why that glutathione level is low, and then precisely target that reason to increase glutathione levels, whether that be through diet, exercise, or perhaps an acetylcysteine supplementation. And that allows us to simultaneously, be mindful to not lose the forest for the trees, but also have the granularity and specificity to zoom in on a single leaf of one tree to see, the veins of a leaf. That is what the data collection, the very advanced data collection that is afforded to us by our GCMS platform allows. And then in combination, we are not performing univariate analyses. We are not looking at glutathione and saying it's low or high. We're not looking at niacinamide and saying it's low or high, or tyrosine or tryptophan. We are looking at the organization of these amino acids and metabolites and other chemical subclasses and mapping them to their known biochemical pathways. In fact, we are able to monitor 68% of all known human metabolism with the breadth of data that we collect. The depth of the analysis we offer allows again, more ontological answer as to why deficiencies or other metabolic aberrations are occurring, and allows us to target that with greater specificity and accuracy.
So as I understand it, it's a more holistic viewpoint of what's happening in the body. So if somebody has like pitting edema, you don't just go, oh, there's inflammation around the foot, let's figure out, like, put some cold packs on there. It's like, well, there might be some sort of heart issue going on. And so we're looking at a larger breadth of data that's giving us a more holistic viewpoint. So in the case of glutathione, it's not necessary to always just supplement glutathione. I can't remember the other thing that you said can be a causative agent to what is producing the deficiency in glutathione. So it's getting more at the cause of why these things might be deficient and what we can do about it. So what was it you were saying about glutathione? A lot of times that can actually be affected by something else in the pathway, and I can't remember what that was.
For instance, let's say the enzyme glutathione synthetase. We observe the enzyme to be significantly depleted, and either in number or activity. And what we can see is that perhaps an acetylcysteine supplementation isn't advised for this individual, because necessarily the enzymes that would create glutathione from this precursor are not functioning. In that measure, perhaps oral or intravenous glutathione would be a more direct and fitting solution for that individual who cannot synthesize glutathione from precursors. However, if an individual, we are seeing, poor consumption of antioxidant-rich foods, low glutathione levels and no deficiencies in glutathione synthetase as per our enzyme enrichment analysis, then it would be prudent for that individual to begin supplementing with N-acetylcysteine, along with a cluster of other lifestyle factors that would most likely need to be amended as well. And so that you're absolutely right, is that it is not sufficient to look at even, let's say, something, a non-molecular marker that everyone's familiar with, something like HbA1c, and to say that your, chronic fat, your chronic glucose levels are low or high. It's because of sugar. It could be because of everything else. We just published a paper in PRJ looking at insulin signaling in humans and corals of all model organisms, and we showed, of course, while as we mapped them and we performed this review article, that there are over 100 different factors, cofactors, metabolic intermediaries, proteins, metabolites involved in insulin signaling. And many of those things, for instance, are not much of those things, I would say, are not captured in a simple HbA1c measurement. You have no measure of glycogen. You have no measure of, calcium, no measure of magnesium, no measure of inosine. All of these metabolites and cofactors play a critical role in maintaining glucose homeostasis and in maintaining insulin sensitivity and a normal, postprandial response to food consumption. Using just HbA1c as a sort of North Star metric, as traditional medicine has, unfortunately ignores 98% of the biochemical underpinnings of diabetes. And in what we in the molecular diagnostics field are aiming to do is herald a paradigm shift away from this known faulty logic that a few markers that we assess only because historically they were easier to assess with the methods available 100 and now going on to 150 years ago. And with the advent of newer technologies and better detection capabilities and more sophisticated algorithms, we are not just able to collect more data on more relevant aspects of health, but we are able to analyze that in a more sophisticated way and produce more cogent results that are actionable to the individual, rather than saying you have high or low HbA1c. That again misses the point entirely, because it's not HbA1c is an effect. It's not the cause. What we're looking at are the molecular causes of insulin signaling and glucose homeostasis.
And as I understand too, so if you look at, and I'm not knocking Genova Diagnostics or really any company for that matter, I think testing is good, right? It gives you information about what's happening in the body and hopefully what you can do about it as well. But there's quite a difference in the amount of data that's produced from, like, say 20, 30, 40 metabolites as opposed to 100 plus or 126 like you're doing. So can you explain a little bit about like why that is not just 80 more metabolites that you're looking at, that the modeling and the relationship between them also is factored in to produce a much like exponential amount of data than what you would get out of just 40, that it's not just like an addition of 86.
Absolutely. It's a great point. And so when we plot number of parameters to number of inferences made, or we should say number of models made on the y-axis and number of parameters on the x-axis, the relationship is not linear. In fact, it's exponential. And so as we add on every new parameter, our modeling capabilities do not increase by a similar proportion. In fact, it's exponential, as I mentioned. So why is that? It's because of the inherent redundancy of biology. When we look at let's say a metabolite like niacinamide. Niacinamide is one very important metabolite because it plays a role in over 17 chemical pathways that we have in our database, and in not just our database, but in the KEGG database, which is sort of the gold standard, one of the gold standards in metabolomics. And KEGG database and other databases like it, like the small molecular pathway database, SMPDB, or HMDB, the Human Metabolome Database, they organize metabolic pathways as discrete sets. And in every set, of course, there are metabolites that appear. For instance, niacinamide appears, and I mentioned more than 17 different pathways. There's only 99 human pathways canonized in this database. And so niacinamide allows you to have partial coverage of 17 of these pathways. What we have done in the Aristotle test is carefully curate our panel to include metabolites that are the most redundant, the most necessary, and the most ubiquitously used across these pathways. And that gives us unprecedented coverage, as I mentioned, of 68% of the human metabolome. Just leveraging that inherent redundancy of biology, we are able to cover 68% of all these pathways with at least 2 metabolites or more. And so with that careful eye to curate this panel to include what we know them as sentinel metabolites, because they are sentinel reporters of these pathways, we have been able to probe deeply into metabolism. Now, as you add on parameters into your panel, your modeling capabilities go up exponentially, as I mentioned. So when you have 126 metabolites, we can actually produce upwards of 15,000 different models. And in fact, we do for every single one of our patient studies that we produce, our customer studies that we produce. 15,000 models have gone into that. That is less than half when you're looking at something like 39 or 40 parameters, which is typical of Genova's metabolomics test. And again, as you mentioned, we are not here to disparage any test. Regular testing is one of the most significant ways to reduce your risk of chronic disease burden in life. And so we are fans of testing, whether it's with us or not with us. But to give an idea of why it's important to have a large and comprehensive coverage of the metabolome and a very large inclusive panel to do that, in addition to the back-end bioinformatics to analyze that data in the context of the pathways and to provide very detailed, nuanced interpretation of that data. That is key in systems biology, and that is not something that is done with the metabolomics test from Genova.
And you also mentioned too that there is a difference between exogenous and endogenous metabolites. So what are some of the factors that you're looking at with metabolites that, say, somebody drinks coffee or they take an ibuprofen or they have some sort of environmental toxicity? What are you looking at on that side of things?
Absolutely. So we are looking at the metabolites that are, of course, central to human physiology, metabolites of central carbon metabolism. Those are like housekeeping metabolites. In addition to that, we are looking at exogenous metabolites like 1,3-diaminopropane. We are looking at various synthetic metabolites that tell us something about what's going on in this individual's environment, in their air that they're breathing and the water that they're drinking. What sort of environmental exposures do they have? Various metabolites that are aberrant in response to mycotoxins, in response to viral infections. Those are the metabolites that we are producing. And so whether they're exogenous or endogenous, we use them for environmental toxicity assessments. And then when you take a look at caffeine is a very prevalent thing, especially in Western countries. And so I'm drinking coffee right now. And in the context of various health domains, it has variable effects. In the context of reproductive health, caffeine is a detriment. In the context of neurocognitive health, caffeine is actually a benefit. And so it is a balance. And so by measuring these very relevant metabolites that are not endogenously produced, they are not produced by the body, but still meaningful in the context of most of our lifestyle patterns and in the context of health domains and their effects on health domains. It's important to monitor these metabolites and not just focus on, vitamins and amino acids, which we obviously have. But in addition to that, we've gone beyond, and we're looking at, measures of, BPA and bitumen and glyphosate and all of these metabolites that are produced from exposure to these harmful substances. These are from exogenous sources. They're endogenously metabolized, but many of them, remain non-organic, and we still detect them with our methods.
So that kind of answers the question of like, hey, what are you offering that might be a little bit different? How is it different? What are the things that you're looking at? Now I want to get into a little bit about the modeling. So some of these companies pride themselves on, hey, the average American is unhealthy. So we actually take a cohort to compare you against that is healthy, thereby matching you against somebody that you can, that you want to be. So you don't want to be compared to somebody that is unhealthy, right? You want to see how you compare to somebody that is healthy. How do you approach that?
Sure. We utilize 10,000 cases of individuals who may or may not be healthy. We have the relevant clinical and demographic metadata to bin them and classify them. And these 10,000 individuals are the result of the Human Metabolome Project. In addition to that, we have our own studies, some of our own studies that meet various inclusion criteria into our database are imported. And so our own research has informed some of these health domains. For instance, our aging index utilizes a metabolite known as cadaverine, which in one of my recent publications, I shouldn't say recent, I guess it was last year, in Geroscience, we proved that this metabolic byproduct, which is a product of bacterial digestion of organic matter or decay, and is therefore named after cadavers. Cadaverine increases linearly from 21-year-olds to 40-year-olds to 65-year-olds. And this linear increase is happening inside of us as we are living. So it is a sort of scary thought to think that you're, rotting as you are alive, but it is very much the case, at least at a molecular level. And so we've incorporated many of these higher impact results that we have, especially those that we have, with sort of, irrefutable statistical evidence, we have imported. In addition to our own studies, of which I think there's really only 5 of which we've imported of our larger body of work, right? Our science team has published over 125 papers together, and in very high impact journals, and we've only imported like 5. So I don't want there to seem as though there's a bias toward our own work. We are actually quite conscious of that and tend to be more discriminatory against our own work than others. And so what we do is, in our database, we also have those 10,000 individuals, our work, but also we have roughly 60% of the 1,300 interventions that we've indexed in our digital twinning database. We also have the raw data that has accompanied those articles on which we have mined that information. And that is a result of a fairly recent trend in academic publishing, whereby there's data mandates that raw data produced from this study must be published online in a public repository alongside the article. That affords us an incredible ability to access that data and mine that data. And it allows us to directly use that data rather than relying on the reported statistics just in an article. Although that's possible, and you can rely on just the, magnitude of change, the directionality of change, clinical significance, power estimates, beta coefficients, et cetera, to make that data relevant to your customers. It is far easier and far more accurate to do so with the raw data. And so as we've entered this new era of academic publishing, where this is more and more the norm, especially for more prestigious journals, we are able at Theriome to then go access that data and mine it and make it relevant to our needs. And so that is where the basis of our comparison comes from.
Let's imagine you just walked into an elevator. There's a physician there that is using a certain metabolomic test, whatever you want it to be. You have 10 seconds to tell them why your test might offer further insight to help his patients. What would you tell him?
I would tell him that if he's looking at a metabolic aberration, we can not only look at that specific interaction between metabolites in a pathway, but we can look at all the other pathways that are surrounding that pathway of his interest and plug into that pathway. So it is not just that we are looking at mitochondrial metabolism. If you're looking at mitochondrial metabolism, suddenly you're also looking at endoplasmic mechanisms of digesting amino acids to plug into the TCA cycle. So it's not just the TCA cycle. None of these really exist in a vacuum. and putting them in these silos of this pathway, that pathway, the other pathway is a human attempt to make sense of it all and create a sort of more discrete solution. So I would say, listen, if you're looking at something like alpha-ketoglutarate for cancers and you're a physician or oncologist who's using metabolomics, I can give you that, but I can also give you all the mechanisms before and after to complete the picture of what you're looking at, and give you more sensitive results, in addition to, again, using our analysis and our analytical capabilities to pinpoint the more, you're looking at really proximal answers. What's the proximal cause of this metabolite? With most metabolic assays, with our assay, you are able to get the distal answer as to what is the root cause of what's happening here and how can I address that efficiently.
If you want to get started with Theriome's testing platform, I can't recommend more. Go over to www.therio.me/guide. You should see it right on the screen here. That's going to give you sample protocols, plus Dr. Jasbi's book on his testing, his methods, how he does everything. That's going to go really in depth on exactly what this is and what this offers and how it might be different from what we've currently seen. This is the future of medicine that we are trying to bring forward. Very cutting edge stuff. So I would encourage you to go to this link, www.therio.me/guide, to get started with your journey. From there, if you get the guide, it's also going to give you an opportunity to schedule a one-on-one with Dr. Jasbi so that you can ask your more direct questions and really get into the nuts and bolts of how this works.